In section 5.5, we're going to talk about approximating the binomial distribution with a normal distribution. This was more useful in the past when we didn't have calculators that would conveniently compute the binomial distribution probabilities. But the idea is still important of approximating one distribution with another distribution. So we want to know in what cases is the normal distribution a good approximation for binomial. So here's a binomial distribution that has a mean of 12, and you can see the boxes for the binomial distribution, and then the darkened in line is a normal distribution that approximates that pretty well. And you can see that there's not a lot of error here between the boxes and the normal distribution. So when does that normal distribution approximate the binomial well? Well, it's going to happen when mean plus or minus 3 standard deviations lies inside the range of 0 to n for the binomial distribution. So that happens up here. So here's 2 standard deviations. 3 standard deviations would be out to about right here and to about right here. And that 6 standard deviation length, that falls within 0 to 20. Let's look at another example here. So here's mean minus and plus 3 standard deviations, and we notice that this is for n equal 20 and p is 0.6, and we notice that that range of mean plus or minus 3 standard deviations is inside of 0 to n. So we got a very nice approximation by the normal distribution. However, here in this example, here's n equals 0 and n equal 10. This is n equal 10 with p is 0.1, produces a skewed distribution. And we can see that that normal distribution is not a good approximation. And here are 6 standard deviations from 3 below to 3 above, does not fall inside of 0 to 10. So we can see that normal distribution would actually continue over here. So, and it's not going to give, there's no values of n that are less than 0. So normal approximation, not good over there. So when that approximation is good, then we can actually approximate those binomial probabilities with the normal probabilities. And the way that you do that is, well, first check that mean plus or minus 3 standard deviations, which is n times p for the binomial, and then 3 times here sigma for the binomial. That lies inside the range of 0 to n. So express your binomial probability then in the form x less than equal a or x greater than equal a, because remember binomial probabilities are for discrete, and so you want to write those in terms of less than equal, greater than equal. And then you calculate z-scores for cutoffs with what they call continuity correction. It's either going to be plus 0.5 or negative 0.5. You just sketch the distribution to see what's going on. And then you compute the z-scores for those corrections, and then compute your normal probability between your 2 z-scores. So let's do the first step here. Let's check if the normal approximation for the binomial is good with n equals 15 and p equals 0.7. So our mean here is n times p, and so that's 15 times 0.7, and let's compute that on the calculator. So 15 times 0.7, so we got a mean of 10.5. And then our standard deviation sigma is going to be square root of np1 minus p. So this is np1 minus p. So for us, that's going to be square root 15 times 0.7, and then 1 minus 0.7, 0.3. Let's go ahead and compute that. So second square root 15 times 0.7 times 0.3, 1.77. And then we want to look at mean plus or minus 3 standard deviations, mu plus or minus 3 sigma. That is going to be 10.5 plus or minus 3 times 1.77. So 10.5 minus 3 times 1.77 is 5.19. And then 10.5 plus 3 times 1.77, 15.81. And then we just need that to fall inside the interval from 0 to n. So is this contained in the interval from 0 to n is 15? Pretty close. The 15.8 goes over just a little bit on the end. But since it's not completely in there, we would say technically no. Okay, so it is not contained in the interval from 0 to 15. So we would say no, normal approximation is not going to be as good as we would like it to.